Okay, I'm back with a quick update on the audio side of things. So I've shown before that the card has this Texas Instruments DSP. So it's the AIC3254. It has the analog, the digital analog, the headphone amplifier, and then it has the DSP core. This is the development board for it, and I originally got this to experiment and just kind of get familiar with the chip a bit, and I progressed to disabling the chip on the board and hooking up the I2C from the board to the PCMCIA card. And what that lets me do is use these built-in this utilities that came with the dev board to do kind of some experimentation with the chip in the card, so I can make different changes to things and see how it sounds. And if you hover over something, it'll show you like what register. Oh yeah, there it is. It's just slow sometimes. It'll show you what page, what register, what bits. It's just kind of a helpful thing to go along with the manual that can sometimes be, you know, you're digging through stuff. Sometimes it's nice just to see it in that UI and come and work on it here. So there's that, and then there's the actual. This is the program. So that was the settings for the actual like chip itself, and then this is for making the program that will run on the miniDSP if you use it. So in my previous examples, I wasn't using the miniDSP. I was just directly routing audio in the chip. And the problem that I'm trying to solve is I had demonstrated playing the CD audio, or sorry, playing any audio out of the built-in speaker of the laptop, and I had shown off uh, the LTE Elite, uh, the compact LTE Elite, and its audio sounded great. It has a pretty big speaker, it sounded good, but the PC110 and some other little PDAs and small things, it sounded terrible, and it's never going to sound as good as a headphone output, but it just didn't sound good. And part of it was I was sending the full uh, frequency range to the speaker. I'm trying to send bass to it and treble, and it couldn't handle it. So the idea here is this example program I've made. It takes the I squared S from the Pico program, and this is the input from the MIDI chip, and I mix them and I go through an equalizer, which I'm not really doing anything with right now. But the key is these filters. So I created these filters, and you can basically set up the data for the filter. How you have all these choices of how you want to do it, and then you can see what the response is going to be, frequency response, and it generates all the coefficients for you. And those are what I have in the Pico program here. So I have one I've created called small speaker, which is a set of coefficients that gives a nice narrow frequency range that seems to be good on the PC110. And then I have one that's flat, which is just everything. So just to show it as an example, if I go into Telex, and there will be all kinds of ways to pick what profile you're on and what the default is. This is just preliminary. I made a menu option in this little interface here called audio settings, and so I have where you can select the profile, so small speaker or flat, whatever. So if I go and start CD audio, which is the easiest way to demonstrate this. So if I just start some audio here, so that's with it. I'll leave this playing in the background. Um, so that's the flat. So it's not doing any processing on it. Now if we go in here and I just bring up that option. So let me unmute it. And you should be able to hear the difference. It's maybe not as dramatic, when you're listening to it on your on a regular computer, but that narrowing that frequency range really lets the small laptop speakers reproduce it, very well, or really good. And so, as an example, so I'd work that out, but you can also go in, if I go into um, this is just some of the example programs from Texas Instruments. If I just enable their small speaker equalizer, actually, and I just have to change the digital input, because they default it different clock for the dev board. And you get the idea. Like I will implement whatever makes sense into to be accessible from the host computer. But yeah, it's this is just a user interface that TI made to one of their example programs. Um, but yeah, and like when you go to these filters, when you go to component interface, it lists all of the. I think I got to stop it. No, it lists like all of how you access the components, and so you get there. My other one I didn't want to open. So you'll see like the component interface. This is, I've created 4 filters, and then it shows you, the the ranges, right? So uh, it's like, okay, it's I2C page 44, and it starts at register 28, and then you can go through and program all the coefficients to those addresses. Likewise, like this is the equalizer. If you go to the component interface, it shows you the start page, and then it also, these are the values you can change, and then this program in it generates the instruction set that you have to upload to the DSP, but it also generates it in a I have it in this miniDSP, so it actually generates these C helper files for you that have all the instructions and coefficients and stuff that need to get loaded into the chip. So you work on your program in here, and then you go to build, generate code, and it just generates the new code that's in the VS Code project. So you just make your change here, then you just go back to VS Code, and you can compile it, and that's it. And yeah, that's the DSP. There will be a lot to improve on it. Like it's working exactly how I want it to right now, but there's so many settings and options you can do to optimize how much how much power it uses. Like, maybe I'm running at a higher clock rate than I need to accomplish uh, the settings that I have. So there's all these matrices that go through what you're doing, and what clock speed you have to run the codec at, and yeah, that's it. So I'll post some more interesting updates over the weekend, but this was just kind of a little brief overview of the DSP. And yeah, this mixer, like this takes in this is the I2S audio that comes from the Pico, so that would have the CD-ROM audio, the emulated Sound Blaster DSP, and the FM and that stuff. And then this section here is taking from the analog to digital converter and bringing it in, and that's the stuff where we have, if we go to analog inputs, we have input 1, which is the Dream MIDI synthesizer chip that we have on board, and then input 2 is this input on this little I/O connector. So either a cable or on this dongle, and then currently input 3 is not connected. And then actually then on for audio outputs, we have the line out routing is what goes to the circuit that generates the PC speaker sound. So line out goes to the internal audio of the laptop, and headphone out goes to the headphone jack. And then you have an example like this, for example, this analog bypass. You have options where for a very low powered PDA or something, if you really wanted to have MIDI, for example, you can disable almost all of this, the DSP core and all of that, and just basically pass the input 1 directly to the headphones. So yeah, this could be a deep rabbit hole to go down all the options that we can do on this chip. So, and that's the kind of the entire flow of it, all our options for the audio, so our inputs and our outputs and how we configure it. So yeah, that's it for now, and yeah, I'll put some more interesting updates over the weekend. Thank you.